Hi General Maths students. So we're going to use the deseasonalised pizza shop data to make some forecasts, so some predictions. So the first thing we need to do is obtain the equation of the trend line. So we're going to do the calculator regression for that, get the calculator to do that line of best fit. And the important thing here, the point is that we need to use the deseasonalised data to do that. We don't use the original or the raw data, we use the deseasonalised data. So that's the deseasonalised data there. So I've entered it into the calculator over here. Right, so you can see that in this list here we've got the number of days. So list one will put all those days, it goes for 3 weeks up to 21 days, and then alongside that I've entered the data in each row, but from that table, but it all goes into one column. All right, so you might want to pause the video now and go ahead and enter the data into your calculator so that you can also get the linear regression and see if you can match the one that I get. I'll give you a chance to do that now. Okay, I'm going to go ahead and obtain the linear regression. So I'm going to go up here and put some headings in these columns so that we can do that. So here we've got the days, so I'll say D for days, and in this column P for pizzas. You can put anything there that you want really, even X and Y will do, but I'll put D and P up there. And we're going to go to menu, statistics, stat calculations, and we get the linear regression number 3 there. The one with the MX plus B. So I'll push enter. All right, we'll select the appropriate variables from the drop-down list. D for days and P for pizzas, and I'll say OK, and here's our linear regression. So the important numbers here are our gradient, n, negative 0.89. I'll go to 2 decimal places on that, so I'll round to 0.89 or negative 0.89, and our y-intercept being 69.35. Okay, I'll see if I can remember those as I go back to the previous page. So the equation looks like this. Y equals negative 0.89x plus 69.35. Now, I'll probably go ahead and put the variables that I used before, so D for days and P for pizzas to, oops, that's the wrong one. P for pizzas there. P for pizzas equals negative 0.89 by D for days plus 69.35. Okay, so there's the equation of our trend line. Now we're asked to mark this on the graph over here, all right? So we actually need to accurately place the equation or the line of this equation over here on this graph. It's going to be a single straight line, not a line graph like what we're seeing here at the moment. So to do that, we need to substitute a couple of x values to get the corresponding y values so that we can obtain 2 coordinate points that are on the line, and that will allow us to mark those 2 coordinate points and basically join them up to make a straight line. So I'm going to put a couple of values in. It doesn't matter which ones I choose. I might choose 5 and 15. Okay, but any 2 will do. So for 5 days, we'll do this substitution, and we'll get a corresponding y value or p value in a moment, and similar but different calculation for this one. Okay. Alright, and I'll just quickly whip those into the calculator. You might want to pause the video at this stage and see if you can get the same values as what I do, or you might choose two different points and see if your line ends up being the same as mine. Because it should, even if you chose two different values other than 5 and 15, you should end up with a line that looks exactly the same as mine. So I'll give you a chance to pause the video and do that, and then I'll move ahead. Okay, so I'm going to move ahead now, and I've put these two values in, and for 5 pizzas, the corresponding for 5 days, beg your pardon, the corresponding value is 64.9 pizzas, and for 15 we get 56 right on the dot. So the two coordinate points are 5 and 64.9 and 15 and 56. I'm going to mark those with red now. Okay, so I'm going to do the line in a red colour. Our original data is in blue, so I want to have a different colour for that. So I'm going to mark these points in red for these two coordinate points. Okay, so 5 and 64.9 is about here. Mark that with a cross to make it look a bit different. And 15 and 56 is about here. Just lining it up, it's about there. Okay, and I'll cross those two. And then I'm going to get a ruler and I'm going to join those up with one single line. Okay, so there is the trend line there. So that's the linear regression. I've just marked it in there. Alright, so we've done that bit. Okay, so now we're asked to make some forecasts. We're actually going to get to do some forecasts now. So, the very next trading day. Well, that means that we're up to day D equals 21. Beg your pardon, D equals 22. Sorry, so the final Sunday was 21. The next trading day is day number 22. Okay, so I'm going to substitute that into the equation and predict or forecast the number of pizzas that we're going to sell that day, or this pizza shop is going to sell. Plus 69.35. So basically just substituting into the equation. And it's all about interpreting what is that number for the very next trading day. Well, we know we're up to day 21 after 3 weeks, so the very next day will be day number 22. Okay, so you might want to pause and see if you can match the answer that I'm about to get, so I'll give you an opportunity to do that. Okay, I'm going to write the answer down now. So I'm getting 49.77. Okay, now because this is a discrete variable, so we're looking at whole number values or integer values, I'm going to round this and say it's about 50 pizzas. To the nearest whole number, about 50 pizzas. And I'll do that on the next one as well. So if you want to pause now and have a go at it yourself, see if you can determine what number day is the following Saturday and substitute that into the equation. Alright, so I'm going to forge ahead here. The following Saturday is day number 27. So that's the number we're going to put in. So the number of pizzas, the prediction or the forecast is 45.32. and rounding that to the nearest whole number value, about 45 pizzas. Righto, so those are our forecasts. In part C, we're asked to determine how reliable these are. So this comes down to those factors that have been discussed throughout this unit. The extrapolation versus interpolation. And of course, we've only collected data up until day 21, and we're making forecasts for day 22 and 27 here. So these are both extrapolations. And I suppose any forecast is an extrapolation. We're predicting outside the bounds of the data that's been collected. The other points that we look for are lots of data and a high R-squared value. Now we've certainly got lots of data, we can tick that off. If we look at the R-squared value back on the calculator screen, it's a little low. Like we're talking, if we look at the R value, we're sort of, oh well, we're still in strong negative territory. Yeah, so the R value, the correlation coefficient's high, but the R-squared value is what we use for reliability of predictions. For determining those, it's not that high. It's only moderately high. So even though our high R-squared value, we're probably not all that high. So I'll put a question mark there. But really, these are not all that important here because of the fact that these are both extrapolations. So we can't consider these to be reliable. So the answer is no, and the reason is that they're both extrapolations, and extrapolations are never considered reliable. Okay guys, so go ahead and try the questions that are in the description for the video and get forecasting.